Section B, Chemical Kinetics 2.1 Experiment. Aim to study the effect of concentration on the rate of reaction between sodium thiosulfate and hydraulic acid. Theory. The law of mass action states that the rate of a chemical reaction is directly proportional to the product of molar concentrations of the reactants. Hence, the rate of reaction increases with the increase in the concentration of reactants. When sodium thiosulfate reacts with hydrochloric acid elemental, sulfur is obtained along with evolution of sulfur dioxide gas. The insoluble sulfur formed during the reaction gives a milky appearance. We can determine the rate of reaction either by rate of precipitation of sulfur or by disappearance of sodium thiosulfate. Rate of reaction can be studied by noting the time in which a cross mark on a paper below the flask becomes invisible due to formation of precipitates of sulfur. Requirements. Apparatus. 5 100 ml conical flask, 2 10 ml pipettes, a burette, a stopwatch, white tile and plain paper. Chemicals. 0.1 m Na2S2O3 solution, 1 m HCl solution and distilled water. Procedure. Study of effect of concentration of sodium thiosulfate. Take 5 clean and dry 100 ml conical flasks and label them as A, B, C, D and E respectively. Figure. Reaction mixture kept on a cross mark on paper. With the help of a burette, add 10, 20, 30, 40 and 50 ml of 0.1 Na2S2O3 solution to the flask, A, B, C, D and E respectively. Now add 40, 30, 20 and 10 ml of distilled water to flask A, B, C and D respectively. Note that the total volume of solution in each flask is 50 ml. Put a mark X with black ink on a white paper. Place flask A on the paper with cross mark A. Put 10 ml of 1 m HCl in flask A containing 10 ml Na2S2O3 plus 40 ml water with the help of burette and start the stopwatch immediately. Observe the cross mark from the top of the flask through the solution. Stop the stopwatch when the cross mark becomes invisible and note the time taken for the cross mark to become invisible. Repeat the experiment for flask B, C, D and E by adding 10 ml of 1 m HCl and record the time taken for the cross mark to become just invisible. Similarly, we can study the effect of concentration of HCl. Observations. Effect of change of concentration of Na2S2O3. Note, the above experiment can also be performed by taking different volumes of HCl in different flasks and adding 10 ml of 0.1 m Na2S2O3 solution in each flask. This will give the effect of concentration of HCl on the reaction. Result. It is observed that T1 is less than T2, less than T3, less than T4, less than T5 from the above record. It is observed that the rate of reaction between sodium thiosulfate and hydrochloric acid decreases with the decrease in concentration of Na2S2O3. Thus, the rate of reaction is directly proportional to the concentration of the reactants. Plotting a graph. On plotting a graph between 1 by T in seconds along the ordinate vertical axis and volume of Na2S2O3 along the abscissa horizontal axis, a straight sloping line is obtained. From the graph, it is clear that 1 by T is directly proportional to the volume of Na2S2O3 solution, but 1 by T is direct measure of the rate of the reaction. Therefore, the rate of reaction between Na2S2O3 and HCl is directly proportional to the volume of Na2S2O3 solution taken. Hence, the rate of the reaction is directly proportional to the concentration of Na2S2O3, which is one of the reactant. Similarly, we can determine the effect of the concentration of HCl on the rate of this reaction. The apparatus must be thoroughly cleaned, measure the volumes of the solution accurately, use the same cross mark for all the experiments, start the stopwatch immediately after addition of reactants, view the cross mark through the reaction mixture from top to bottom from same height for all observations.